Greetings, friends. My name is John Gabriel, and this is the new Calculus channel. So today, I would like to talk about the topic of number lines and which number lines actually exist and which do not, and also point out some of the flaws in mainstream thinking. So let's begin. Now, there are several requirements in order to manufacture a number line, and the real number line has to meet these requirements. And we'll see in a short while what it means to reify a number line. But in mainstream academia, mathematics academia, they imagine that every number corresponds to a point on a real number line. But that's not possible because points have no dimension or extent. So you might say, well, actually it corresponds to a certain distance. Well, that can only work if the distance is constructible, first of all, and second of all, if we can measure that distance, okay? Because a number describes a number is a measure that describes a distance. All right, so we'll get to all these topics in a second. So I've got this article which I'll post a link to, and all I want to do is show you the three basic requirements for constructing a number line. So you'll see that to reify a point, okay, what does it mean to reify a point? It means to be able to set up a point on a number line. Well, first of all, we need to do the following thing. We need to be able to construct the line segment, to assign the markers as in calibration, right? And also to provide a measure for each marker. Okay, in other words, give it a name. Otherwise, how do we know? Now, we can't really give any marker the name pi because pi is not a number, okay? And if you read this article, you'll see there's a link here which shows you this link here, which will show you why pi is not a number and how we get numbers. There's also a link to my article on how we got numbers. As I'm no longer on LinkedIn, I've moved these articles to a separate place with new links, and you can read those, study them. So now, in order, for example, to construct getting my tongue all twisted up here. In order to construct a number line, we need these three requirements, okay? And we usually start off with ratios, and we assign a distance to the unit. As you see in the first ratio there, 2/1, we assign that distance as the unit or the consequent. This here is the consequent, and this here is the antecedent. And if we have a magnitude that measures both the antecedent and the consequent, then this would graduate to a number, okay? As you see this number up here. That's why we use the vinculum to denote the number and the colon to denote the ratio. Okay, so I'm not going to go through the entire article because you can read it and study it with all the links. These are links, and you can see why there is no such thing as a real number line. Now, mainstream academics are alarmed because they imagine if there's no real number line, then there are gaps on the imaginary real number line. There are no gaps because if you think of the real number line in terms of magnitudes, okay, so in other words, you don't have to say x is an element of R. You can say x is an element of M if you're using set theory, which you shouldn't be because set theory is a bunch of garbage. But M is just any magnitude or distance, see? So it doesn't matter where you are here. If you had to, for example, if you had to try to find pi over there, as we have like so, whoops, pi, okay, 3.14 approximately, whatever, then it's just taking the distance pi and outputting another distance, which may or may not be measurable. So for example, if we've got the square root of 2, and we put the square root of 2 in as input, we're going to get 2, which is a rational number, okay? Square root of 2 approximately to a rational number. So it doesn't really matter that we have a number line in which we have real numbers, because real numbers don't exist. There is no such thing as a real number, okay? And we have to remember what the definition of a number is. A number is a name given to a measure that describes a distance or a magnitude, etc. So we don't need any of the rest. Now, that's all I really wanted to cover with you in this video. It's very important because there's a large debates about dark numbers, and other really weird ideas involving infinity. We don't need any of those ill-formed concepts, and we can actually use calculus without any real numbers, as my new calculus proves, and as you will learn if you read this article. So I don't want to continue to blabber on and on. I'll leave you with this. If you're not already a subscriber to my channel, be sure to become a subscriber, spread the news of this channel, and click like so that others can get to know this wonderful information that has been hidden from the mainstream. Also remember to download my free ebook. This is the New Calculus channel, and I'm John Gabriel. Till next time, folks, goodbye.